let us talk about this character. This character is a part of the third person template. This template consists of all the animations, blueprints, and input mappings for this character, which helps us to control this character to roam around this level. You can find this character inside your project browser. Just press escape to exit out of this game mode. I will go to the content drawer, and inside this content folder, we have this characters folder. Inside this, we have two folders, one for the Unreal Engine 4 character, and one is the Unreal Engine 5 character. So it's called the mannequin character. So the Unreal Engine 4 mannequin, if I go to the meshes, it looked like this. Whereas the Unreal Engine 5 mannequin, I can go back to this folder, and if I select the meshes folder, so the Unreal Engine 5 mannequin looks like this. So this folder consists of the textures for these characters. So actually we have two mannequins in Unreal Engine 5. One is named Manny and the other character is named as Quinn, which is currently we are controlling. We have the textures for both of them and the materials which are made up of those textures. Then we have some material instances, which are just the copies of the material. Then we have the animations for both of these mannequins. So if I just select any animation and just double press to open it. So this is the animation controller where you can look at some preset animations here. So we have this idle animation. I just double press on it. We have this jump animation, running animation. So all those animations are part of this third person template. I can just exit out of this. Then we have some rigs, which helps us to control the animation. It will help us to actually make the animation as well. Inside this third person folder, we have the blueprints of this mannequin. So the blueprint is actually defining how those animations will work. Like when I'm pressing W, our character is moving forward. How it is happening? It is happening inside the blueprint. We are just defining that when I'm pressing W, we will be playing the forward animation. When I press A, the forward animations will be moving in the left direction. And likewise, I can just double press to open this blueprint. Now we'll not go through this event graph. Let's go inside this viewport. So inside this viewport, we have our character. So in the left hand side panel, we have our character. Then we have the collider for this character, the mesh for the character, and the camera through which you will be seeing the character. Notice that if I move my camera forward, suppose like this, now to save this, firstly we need to compile and then we'll press save to save all the changes. Now if I press play, notice that our camera is now closer to this mannequin. So that camera is actually defined from here. If I move this backwards and suppose above, to save changes, I first need to compile and then I will save it. If I press play, now you can see that the camera is a bit above. So that thing is controlled inside the blueprint. I can just press Ctrl Z to undo all my changes. So as I said, inside the blueprint, we have three components. We have the viewport, we have some construction script, and the event graph. We'll not go through the event graph and control script. We'll just discover the viewport for now. We'll be discovering blueprints in future lectures. So our character has some properties over here. So you will see that our character is able to collide with different objects. Why is it happening? It's because our character also has the collision and the other actor also has the collisions. So the collisions for the character is actually defined inside the mesh. I will select this third person character or this one over here. Select this mesh. I can just press this button over here to browse this mesh inside our content browser. So this is the mesh. I will double press and it will open. So this is the character mesh browser. And over here, this is actually different from the static mesh. So the static mesh are the simple 3D objects, whereas the character mesh are actually a mesh which is defined for the character. If I go over here and select this option over here, we have something called as the skeletal mesh. So the character always have a different kind of mesh, which is different from the static mesh. It is called as the skeletal mesh. So the skeletal mesh is actually a human skeleton, which is inside of this 3D object. If I just open any normal mesh, suppose I go over here inside this shape, this one. So this is a normal static mesh. So the static mesh has this kind of icon, whereas the skeletal mesh will have this icon. So the static mesh does not contain any skeleton or any properties because it is just a static. It is just placed inside our level. Whereas the skeletal mesh consists of a skeleton. On the left hand side, we have the skeleton tree. Now, if I select any bone over here, so all these components are represented as the bones. Now, if I select show over here, or if I go over here inside this character and bones, and if I go to all hierarchy, it will highlight all the bones inside this character. So here you can see we have this neck bone, then we have this shoulder bone, upper arm, we have this lower arm bone, then we have the bones for all these fingers. So why are these bones needed? So these bones are actually needed to perform the animations. If there are no bones, it is just like a static mesh. So to have the humanly animation inside of a character, we actually need a structure for that character, which is similar to the structure of a human body. So this structure is this skeletal mesh, which is actually similar to the structure of the human body, the skeleton of the human body. If you look closely, you will see that all these bones are actually the joints inside the human body. Suppose this bone is representing the elbow joint. These over here, these are the finger joints. Then we have the knee joint. Then even for the foot, we have the joints. So actually, more the joints that you have inside your skeletal mesh, more the accurate your animation will become. Let me demonstrate it. Suppose I select this upper arm phone. I can actually rotate this and notice how the whole arm is moving upwards. Then I can select this elbow joint over here. and I can rotate this as well. Rotate it this way. Then again, we can select these joint over here and just rotate it, and look how easily we can rotate each and every joint inside the skeletal mesh like this, like this. We can select. So now if I automate this process of selecting the joint and rotating it or moving it, we can actually create an animation inside the level sequencer. So this is how the animation is made for each and every character. So the animation is actually purely dependent upon each and every joint and the skeleton. Hence, adding a skeleton inside the body of a static mesh is actually called as rigging. And the rigging is used for animating any body. Just press Ctrl Z multiple times to undo all the changes. So, like this. So this was the skeleton tree for this skeletal mesh. Then this is the skeletal mesh itself, which has all the materials and other properties. Then we have the animations for this skeletal mesh. Notice that how the bones are moving. So you can see if I selected any bone, you can see how its rotation property is moving. It's according to the animation. So for the jump, you can see how each and every bone is animating. Then over here, we have the animation controller. I will go back to the skeleton mesh. And over here, we have some physics properties. If I go to the search browser option, and I will double press it to open. So this is the physics property for the skeletal mesh. So all these bubbles that you're able to see are actually the collisions for this mesh. So these are called as the collision hulls. If I look closely, so all these bubbles are actually covering the whole structure of this skeletal mesh. So this is actually different from the collisions of the static meshes. If I just go over here, so the collision in here is different from the collisions inside the skeletal mesh. So these collisions are called as the collision hulls. So over here, if I just select, so each and every bone has its own collision hull, which makes it more precise. So when you are colliding with any physics actor, such as that blue cube that I was talking about, so that is because of the collision hull. So let me show you. If I just press play, you can see how we are able to collide with this cube. It is because of the collision hulls of my character and the collision of this cube. If I go inside this show mode, and we can actually select the collision to show like this. Now we are able to look at the collisions, those thin blue lines. So these are the collisions for this cube. We press play, and let us get out of this game mode. I'll press this tilt button, and if I press this button over here, it will actually detach my controller and it will actually keep the game on, but we will be inside the viewport. So right now we are inside the viewport, but we are outside the game mode and the game is still running on. You can see over here that all those collision hulls can be seen. And likewise, we have the collision for these cubes. So that is how the two actors can collide. If there are no collisions for this character, then it won't be able to stand on this ground. So that's why the collision hulls are needed.